Okay, in this tutorial, I'm going to show you how to communicate with your Arduino microcontroller via a VB computer program here. If you're like me and you like messing around with your microcontrollers, and you want to be able to communicate with them from your computer to be able to turn lights on and off, or control a relay or whatnot, you need a way to send and receive data through your USB port. And there are tons of different ways to do this. However, this is one of the easiest and most efficient ways. This does not involve buffers or having to clear out anything. It's straightforward communication. I don't have any issues with speed or with it filling up any buffers or anything like that, because I'm not sending big long strings or big long commands. It's just simple words or simple little phrases. So here we go. We're going to start with the Arduino code here. I'm just going to kind of walk you through it. I'll post all this code with this video, and I'll post all the code for the Visual Basic program as well, and I may even include a link for a zip file for both of these. But we need to start with the Arduino IDE code here. As you can see, I've got quite a bit here. It's not too much, but all this code is going to do is turn an LED on or off based upon the code received, or based upon a little phrase received from the computer, and it's also going to let the computer know whether the LED has been turned on or off, and the state of the controller, meaning if it's connected or if it's not connected to the actual computer. So first off here, we have our pins and we have our variables. These two variables here are just to receive the command from the computer, and then this one is just to initialize the LED pin on the microcontroller. I'm using pin 13. I'm also using an Arduino Uno. And it is connected to my serial port COM3. I have two controllers currently connected, but COM3 is the one that I'm going to be using for this tutorial here. I have my void set up, and in there I have to connect to the serial port. I have it to begin it, and I also want it to print out a message saying that it's been connected. So I have my serial port, 9600 baud rate, and then the little serial message that's going to say it has been connected. Okay, and then I also declare that my LED pin is an output. So in my loop function, I have quite a bit going on here. I'm going to start determining if there is any serial data available. So I call my serial.available, and then I'm going to put a delay here. I have found that there has to be a delay, or else the Arduino cannot distinguish between one command versus another. So if you are sending a command to the Arduino on a timer-based function, and you want it to happen rather quickly, you can't really do more than a few a second. You can't, send 1,000 commands in a second and expect Arduino to be able to comprehend it. This computer here has 8 gigs of memory, of RAM, and the microcontroller that I'm using is like 32 kilobytes. So there's quite a difference between the processing power. So there needs to be kind of a slowdown so the microcontroller can actually catch up, even though we're not sending very big commands. So I start off and I say, okay, if there is data available, then I need to do a loop. So I start with a loop to receive the very first bit of my command. My commands are broken down using the @ symbol that declares a new command, and then the hashtag symbol is the end of the command. That way, the Arduino knows, okay, this is the command is in between these two symbols. You don't have to do it this way. I just found that it's a lot easier for the microcontroller to be able to distinguish between the commands. So here we go. I start with my @ symbol, and once it sees that there's an @ symbol, then it's going to search for a hashtag or a pound sign, whatever you want to call it, and it's going to, in between the process of searching for that hashtag sign or the pound symbol, it's going to take all that it sees in the middle, and it's going to add it to one big string. You can see my SER, short for serial, is my string that I declared up here, and my comp in is my character. And so we're going to receive this string one character at a time, and then we're going to put it into a big long string. And then down here is where I have all of my reading commands. So it's going to search in that string. It's going to say, okay, is this string, does it contain LED on, or does it contain LED off? Now after here, I could put a whole bunch more. So I could, start a whole new if statement, and I could have, if serial equals, LED turn on and flash, then it would do a command. Maybe it does a few delays and it flashes the LED for a second. So this way it's set up and I can enter any command I want. Just by using this @ symbol and the hashtag sign, it's able to determine the command that I'm wanting, and it's also able to distinguish between multiple commands. That way I can have 8 or 10 commands here, and I don't have to make sure that they're not named the same thing. I can name the next one LED on 1 instead of just saying LED on. You find in your programming that there can be a problem whenever you have two things named very similar, or they take up the same amount of characters and they contain the same letters. Depending on how you program, you can run into these issues. So I have just eliminated it with using the making like a symbol. So anyways, if it determines that the LED is on, that it's wanting to turn the LED on, then it is going to turn the LED on with this little digital right, and then it's going to have a small delay, and then it's going to send a command via the serial port, and it's going to say LED on. So that way it lets me know that the LED has been turned on. And then if it determines that I'm wanting to turn the LED off, then it's going to go ahead and it's going to turn the LED off, and then it's going to give a little bit of a delay for everything to kind of settle down, and then it's going to go ahead and it's going to turn the LED off. So I went ahead, uploaded this to our microcontroller. Unfortunately, you cannot see my microcontroller working. You're just going to have to take my word for it, but you will know that it is working once we get into the Visual Basic program. So this is what you're going to need for your microcontroller. Now let's jump into our VB program here. I just programmed this simple program in Visual Basic 2010. I had 2012 and 2008 installed, but this is just kind of easier, and it's more universal, I guess. Not a lot of people have the 2012. They work the same way though. I will go ahead and I will start from scratch, and just to kind of walk you through the process here. So you're going to want to open up a new Visual Basics. Okay, get rid of the start screen. Okay, you're going to go to File, New Project, and then Windows Form Application. Okay. When you save it, it will ask you to change the name and save it to your location. I'm not going to save this one. This is just my test one. I already have all the code in this project right here, and this one is saved. This is probably what I'll put in a zip file for you guys. So you're going to go to your toolbox, and you're going to put whatever parts you might need on there. For starters, we are going to need a serial port. Okay. We're also going to need a timer. Okay. We're also going to need a button. Actually, we're going to need two buttons, and we're going to need a label, so I'll put the label on there. Okay. We're going to need the button. So we put our button. We're actually going to need two buttons, so we're going to copy the button and paste it here. So now I have two. I just use Control-C, Control-V. I also don't want my form that big, so you're going to need another label, so Control-C, Control-V gives me two labels here. You can rename these just for the sake of time. I'm not going to worry about renaming them. They are renamed, and they're all to standard programming conventions on this other program that I have already made. And you're going to go into their click events and stuff. So I'm just going to show you how I built the interface. So this is it. Now the serial port here is what gets kind of tricky, because there are a whole bunch of different properties for the serial port here, and on the program I'll go to it in just a second. I'll show you what to change, but this is what they look like standard, and you're going to need to change some of these. So for starters, the baud rate, keep it at 9600. You can up it or you can lower it. It just kind of depends on what microcontroller you have. Thankfully 9600 works for what I'm using. Data bits can stay at 8. Discard null can stay at false. DTR enable we need to be true. Okay. And then when you come down here to port name, you're going to name that your COM port. My COM port happens to be COM3, so I'm just going to rename that to COM3. Okay, your read buffer size needs to be changed to whatever your sending baud rate is, which was 9600. So I'll change that to 9600 here. Okay, your read timeout can be -1. Received bytes can be 1. RTS enabled though will have to be true. Okay, so this is now set up. We are ready to go, ready to code. So I'm going to go ahead and I'm going to close this out. And we're going to go back to what I've already programmed just so I can show you the code for time's sake. So you can see here's my serial port. You can see all those things have been changed. So I have my DTR enabled, 9600, COM3, RTS enabled. So everything's standard. My timer here, I just left it all default. I will turn it on and set the interval inside of the actual code itself. So I'm going to go ahead and I'm going to go to my form load event. If this is one of your first Visual Basic programs, just double-click the form. Anywhere on the form that there's not something, and it will take you directly to the form load event. If you click a button, it will take you to that button click event, click a label, label click event, whatever. So form load, we're going to need to import system.io and system.io ports for it to be able to communicate with our serial. And once you do that, that's all you got to type there is a little code. You're good to go. So now we have our form load event. On our form load event, we are going to need to declare our serial port, which is COM3 in my case. It could be COM5, COM50 in y'all's. It doesn't really matter. So serial port 1 dot port name equals COM3 lowercase com with a capital C. I haven't really played with that. I don't know if you can change it. If you can, cool. If not, then just keep it like that. And then you're going to want to open this port. This means that this port is now ready to have communication both back and forth. So right here is where I enable my timer. So I put my timer as a 1000 tick event. So every second it's going to tick, and it's going to do whatever function. And I'm also going to enable my timer. So I come down here, and here's my timer event right here. So I'm going to declare a read serial variable as a string. The Arduino IDE and the Visual Basic is slightly different. The Arduino reads it character by character. However, the Visual Basic can read it in one big kind of lump sum, but it takes a lot more effort to do it that way. So we're gonna also treat it kind of like an Arduino, and we're going to read it byte by byte. So we're going to say, okay, put all these bytes that are in the serial port, put them in this string read serial that I just created up here. And so it's going to read the existing inside of that serial port. So like I said, it doesn't read it character by character, but we're in this case we're having it read it character by character, but all at one time. So we don't have to have any loops. And then we also have our little commands here. So to start out with, as soon as the controller is connected to the computer and this program is launched, the controller is going to say connected. And so if we receive this connected phrase, then we're going to display a message box that the controller has been connected. Now if we read back that LED off, then we're going to know to change the LED status that it is off. So that way the form will change and it will say LED is off. Same with up here, if we receive the LED on, then the label status is going to be LED on. Now I'm using read serial.contain, so I'm seeing if that string contains this phrase, just in case the string has more than one phrase built in for some reason. Maybe I kind of like to think of it being on back order, so maybe there's a couple of phrases built in. That way it can read all those phrases, and it will start with whichever one I have programmed first. So let's say the phrase that the serial actually contains is LED off, LED on. Well, it is going to determine that the LED is on, and then it's going to determine that the LED is off. So that's just the order of which I have programmed this in. So then we come down here and we have our button click event. So this one is for my button click on, and this one over here is for my button click off. So whenever I click the button to turn the LED on, I'm going to want to write to the serial at my @ sign, LED on, hashtag. So this is my phrase. So you can see this piece right here is all the microcontroller cares about, and it's going to look for the phrases between the @ symbol and the hashtag sign. Same with the LED off. So @ symbol, LED off, hashtag. If we go back to Arduino IDE, we can see that it is going to look for this right here, the serial LED on and our serial LED off. It's going to look for those phrases that have been sent from the USB to the microcontroller itself in those particular phrases. Now, you can see that if it receives the signal or receives the phrase LED off, it's going to send the phrase LED off so that it kind of confirms it. And you can see I left it lowercase for the receiving, and then LED off for the sending, all in uppercase. You can do either one. You can do uppercase or lowercase. I tend to keep it all one. That way I don't have any confusion when I'm going back and forth between the Visual Basic program and the Arduino program on what letter did I capitalize, what letter did I not capitalize. Just makes it a little easier. So I'm going to go ahead and save my Arduino IDE, and I'm going to load it up. So I'm going to compiling the sketch. It's going to load it to the microcontroller. And just to confirm that this phrase will actually work, I'm going to go ahead and I'm going to use the serial monitor. So I'm going to go to Tools, Serial Monitor, and you'll see that it says connected. So this is the output of the microcontroller. So now I'm going to input @LED on. Okay, hashtag. Okay, it sends a signal. Now you see it return the LED on. So that's right here where it says LED on, It's now returned LED on, and I'm looking at my microcontroller, and if you guys could see it, you would see that my LED attached to pin 13 is on. And I can send @LED off with the hashtag, and it will return LED off, and I can check and see on my microcontroller that in fact the LED has been turned off. So I can close out of that. This is good. I'm going to go ahead and save my Visual Basic program, and I'm going to play it. So you'll see it's going to load. Okay, here's my main form, and then here we go. Here's my message box. So the controller is connected. So now the controller is ready to send and receive commands. So now if I click the LED on button, my LED on my microcontroller turned on, and you can see the status changed. And if I say LED off, okay, you can see the status changed to LED off, and the LED on my microcontroller is in fact off. So I can close out of that, and once again, this is the receiving port of the serial, so you can see that the LED, whenever it receives that command LED on, like you saw in the serial monitor on the Arduino IDE, it's going to change the LBL status, which is this right here, LBL status. It's going to change its text to saying LED on or LED off. So this was a quick little tutorial on how to establish a simple communication with an Arduino microcontroller, and really any other microcontrollers that can communicate with standard ASCII characters via USB. Now you could use a serial connection, or you can just stick with USB, or you can even go as far as to do Bluetooth and have a Bluetooth serial and a Bluetooth sender and receiver. One connects to your computer, one connects to the controller. I just found that the simplest way to do this was use a timer function instead of actually have to worry about the serial port read commands. There's a lot more helpful information on this on Microsoft, but like I said, this is one of the simplest ways to do it, and I have not had a problem with it, and I even run more complex programs. Just an example, here is my program that controls all of my lights and stuff at my house, just a fun little automation program that I did. It's called Narvin. Here's my main event. This right here houses all my cameras, so I can have a live stream of them all. I can control things such as the lighting, and I can control things such as the garage door, things like that. And so this one has a way more complex system, and I use the same protocol with my @ and hashtag sign to distinguish between sending and receiving commands. This runs on the computer 24/7, and I don't have an issue with it. Here it is actually running. So I can turn lighting on and off, all that good stuff. So anyways, this was just a quick little tutorial. I hope you guys find this helpful. If you guys have any questions, feel free to message me and ask me about them. I'm posting this on YouTube, and there will also be an Instructables on this as well. Have a great day.